Hi everyone, welcome. In this lesson, we're going to continue with our exploration of categorical logic. So last week, we introduced ourselves to the four standard form categories of propositions that can be dealt with in categorical logic. And if you recall from those lessons, categorical standard form propositions take four types. We have our A propositions, the universal affirmative, all SRP. And then we have our E proposition, universal negative, no SRP. We have our I proposition, particular affirmative, some SRP. And we have our particular negative propositions, some S, are not P. We then explored some of the properties that those propositions all have. They have quantity, they have quality, and they have distribution. So I want you to beware that that's information you're really going to have under your belt as we move forward and build up to the square of opposition, which will ask us to apply that information to further problems. In this video, we're going to have a look really at some of the same ideas from a different angle and explore the meaning of formalization in a little bit more depth as it pertains to categorical logic. So just as a brief kind of overview here, we did our little recap of our four types of proposition. We'll do a little more practice on that. I want to explore in more detail what it means to formalize ordinary sentences. We had a little bit of a look at this in chapter 1 where we explored how to identify the parts of argument, but we'll explore it in more depth here as it pertains to categorical standard form. And I want to talk about argument form a little bit more and just try to uncover some of the basic building blocks that we're going to be increasingly work with as we deal with what it means to have a valid deductive argument. Okay, so what is formalization? Well, we learned that there's a difference in logic between content and structure, and form really is that underlying structure of every argument. And when we dealt with deductive arguments, we talked about the difference between formal analysis and truth value analysis, right? Truth value analysis had more to do with whether or not the information in particular premises is true in a factual sense. And that's very different from a formal investigation into whether or not the parts of an argument are related in a logical or rational manner, right? So formalization allows us actually to look at the structure of an argument without having to spend so much time really thinking about whether or not information in premises has a true value. Okay, so it's easier to suspend judgment on the truth value or regarding the truth value of the elements of an argument and to just focus on logical structure if we formalize the argument. And by formalize, I mean reduce it to its most abstract underlying structure. I like to think of it as that when we're formalizing an argument, we're like taking an x-ray of an argument that we might be giving to one another in ordinary life, but without perhaps thinking so much about the structure, right? So we're going to study a couple of different methods of formalization in this class, and I just want you to be aware that each of these types of formalization are very different and will allow us to do very different things, but that we can't really mix the tools that belong to one and transfer them very easily into the other, unfortunately. All right. We have on the one hand what is called categorical logic, and that's really what we've been dealing with in the past week. Categorical logic reduces non-logical vocabulary to class terms or categories. I'll talk about what non-logical vocabulary means as opposed to logical vocabulary, but as you recall from the past two videos, categorical propositions deal with classes of things, right? And we broke down those classes of things into subject classes and predicate classes, right? So that's really the basic ingredients of categorical logic are subjects and predicates separated by copulas. There's then this entirely other different branch of formal logic known as propositional logic. We're not going to be studying it until later in the course, but we are going to be studying it. So I'm just sort of flagging it for the moment as an important area of formal logic that's very different. Propositional logic reduces non-logical vocabulary to variables that stand in for statements. So propositional logic is very abstract and almost mathematical, and will involve, in a way, a much more minimal and bared down version of logic that will allow us to do quite a lot of things with it, but it'll take some time for us to build up the necessary tools to do that kind of formalization. Okay, so let's have a look at our argument form in categorical logic. If we have an argument like this, an ordinary language argument like this, all philosophers are persons. And then we try to think about the parts of the sentence here, the premise, in terms of logical vocabulary. I have highlighted in purple here what we would call the logical vocabulary. That is the terms that sort of fit very cleanly into units that are recognized by formal logic. All and are known as logical vocabulary because they are easily picked up or flagged as the parts of a formal argument. All is our quantifier. It lets us know we're dealing with something universal, right? And then are is our copula, our verb to be, which is the part of sentence that sort of separates but conjoins the subject class with the predicate class. We then have non-logical vocabulary, and that just means the terms here that fit into the subject and predicate. And these are non-logical terms because they are classes of things. In other words, they refer to very specific content out there in the world, and the content is in a sense less important to the ways in which these class terms are actually relating to each other in terms of their distribution. So, as I've said before in previous videos, logicians hate content and they love form. Or maybe they don't hate content, but they find content difficult to work with because it's not as universalizable. It's not as easily generalizable. So we love to turn non-logical vocabulary into logical vocabulary by substituting out that content for things that are a little bit more easier to recognize by logic. So we reveal the statement form by replacing the class terms with letters, and those letters are arbitrarily selected. Much as in algebra, you use variables to stand in for parts of an equation that you don't know. We will use letters to stand in for these non-logical class terms in order to reduce them to their simplest component parts. Okay, so we're going to use the letter P to stand in for the class term philosophers because we have P, at the beginning of the word. But bear in mind that really the use of that P, that letter, is really arbitrary. It could be any letter in the alphabet as long as we're consistent in our application of the letter across the argument. And then we're going to use the letter Q to stand in for persons. We can't use P here again because that'll confuse the term philosophers with persons, right? So even though there's no Q in this word, we're going to use Q as our agreed upon statement form to stand in for the class. So P will represent philosophers and Q will represent persons. So we're going to rewrite this sentence in a formal way, and then when we see the underlying structure, we get this: all P are Q. All right. So this is equivalent to all philosophers are persons if we have agreed on P standing in for philosophers and Q standing in for persons. Okay. So that's really how you formalize an argument, right? Formalization is just kind of a process of translation, really, of turning an ordinary language sentence into kind of this formal structure. All right. So the first thing we got to do when we have multi-part arguments is to determine conclusions and premises, right? And then we have to isolate our logical vocabulary from our non-logical vocabulary and make sure we're not subbing out parts of the argument that are recognizable as logical terms and conflating them with non-logical terms. We have to rewrite the class terms with symbols to replace them, right? And we have to make sure we are consistent in our application, in our usage of symbols to replace the class terms across the argument. All right. So again, the usage of the letter is totally arbitrary. It doesn't matter which letter you use, as long as you are not repeating letters that will confuse different class terms. Okay. So if we have an argument like this, we have two premises and a conclusion. First premise says all persons are mortals. Second premise says all tax accounts are persons. I think this should be accountants. Yeah, sorry, accountants. Therefore, and notice we're going to use our nice horizontal line here to indicate the separation of the premises from the conclusion. Our conclusion follows the line. Therefore, all tax accountants are mortals. Okay, this is a very standard argument. To formalize it, we're going to isolate the non-logical vocabulary, and we're going to substitute those terms with letters to represent them. So let P represent the term persons. Let M represent the term mortals here. And let T represent the term tax accountants. Again, any letters would work, but I think it's helpful and easier to use letters that appear in the word in question so that you can kind of, at just the glance of an eye, equate them more easily, perhaps. Okay, so write out this whole argument, and now let's write out the formal version. The first premise becomes all P are M, where P represents persons and M represents mortals. The second premise becomes all T are P, where T represents tax accountants and P represents persons. And now try to write out for yourself the conclusion. How would you formalize? Therefore, all tax accountants are mortals. All T are M, where tax accountants is substituted with T and M is substituted for mortals. Okay, pretty straightforward. We have a repetition of our P term, we have a repetition of our M term, and we have a repetition of our T term in different positions. So you might try to think about what that might tell you about this argument, whether or not it's valid. We'll explore in future units the structure of categorical syllogisms, where we'll be able to pick up very readily the placement of these terms in such a manner that we can discern validity from invalidity. But for now, just focus on the process of stripping down this content to reveal the underlying form. All right, let's look at another example. All geese are migratory fowl. All geese are migratory fowl. Whoops, let me get out of the way here. All migratory fowl are birds that fly south for the winter. Therefore, all geese are birds that fly south for the winter. And apologies, we should have a horizontal line here to denote the separation of the premises from the conclusion. Yeah. In any event, therefore is a good indicator term of conclusions, right? Okay. So let's try to formalize this by picking up the non-logical vocabulary and representing it with letters. Let's use the letter G to represent geese. Let's use the letter M to represent migratory fowl. And let's use the letter B to represent bird that flies out for the winter. G, M, and B will be our symbols for our non-logical terms. Now please rewrite this whole argument formally using the symbolic notation as substitutes for the class terms. Okay, our first premise should look like this, right? All G are M. All G are M, where G represents geese and M represents migratory fowl. Our second premise should be all M are B. All M are B, where M represents migratory fowl and B represents birds that fly south for the winter. And our conclusion should look like this. All G are B. All geese are birds that fly south for the winter. All right. So again, we have a repetition of our M class in the predicate term and subject term. We have a repetition of G in our subject term in the first premise and as the subject term in our conclusion. And we have a repetition of our B term as the predicate in both the second premise and the conclusion. Now think for yourself for a moment about the type of category for each part of this argument here. If we return to our categorical proposition forms, we have, if I can write here, this is an A proposition, right? This is our universal affirmative, where all G are M. We have also an A in the premise, all M are B, and then we have another universal affirmative in the conclusion, all G are B. So you can have a syllogism, a three-part argument, that all take the same categorical form. They can all be universal affirmatives, as this one is, right? Okay, so that's just an example of formalization. Let's move on here and do another one. If we have something like this, no dolphins are dogs, no dogs are cats, all dolphins are cats. Let's formalize this by substituting out the non-logical terms with letters. Let's use D to represent dolphins. Let's use G to represent dogs. I'm only using G because we've already used D for dolphins. And let's use C to represent cats. So rewrite this argument in formal standard form using these letters as the symbols for the non-logical terms. Okay, your formal argument should look like this, right? No D are G, no G are C, therefore all D are C. All right, and again, if we were to think about this in terms of the standard form notation, this is an E proposition, this is a universal negative, no D are G. We have another E proposition in the second premise, no G are C, and then we have an A proposition in the conclusion. This is a universal affirmative. All D are C. All right. So notice we're not thinking about truth value here because you can probably pick up on some issues of truth value. But here we're just looking at formal structure. Let's look at another one. This argument says all cats are friendly. Everything friendly is cute. Therefore, all cute cats are cute. And again, if we're being consistent here, we would have a horizontal line to indicate the conclusion. I'm just going to very badly draw a horizontal line here. Okay, so we have our premises separated from our conclusion. Now, in order to formalize it, let's agree upon some symbols to represent the non-logical terms. Let C represent cats, let F represent friendly things, and let U represent cute things. So rewrite this argument using this chart of symbols to stand in for the non-logical terms. Okay, our formal argument should be all C are F for the first premise, where C represents cats and F represents friendly things. Our second premise should be all F are U, where F represents friendly things and U represents cute things. And our conclusion should be all C are U, where C represents cats and U represents cute things. So notice we had to modify this a little bit in order to fit the content into standard form. We had to use stand-ins for friendly. We had to transform friendly into friendly things because categorical logic is working with classes of things. This is just not just working with these sort of free-floating properties that English sentences can do. We have to somehow kind of fit a square hole, fit a circle into a square here, as it were, in order to get standard form. So if we think about what category each of these premises are, our first premise you should be able to see as an A proposition again, where all C are F is a universal affirmative. The second premise is also going to be an A proposition, all F are U, and again our conclusion, another A proposition. So all three sentences in the argument are universal affirmative. All right. So just to highlight or underscore again the work we had to do to formalize this adequately, the sentence on the left, everything friendly is cute, is a perfectly meaningful sentence in English, but it won't translate immediately into standard form categorical logic. We need to tweak it. So in order to tweak it into one of our 4 types of sentences, we had to translate F into friendly things. We had to treat it as a class of thing. Right? And that you are allowed to do that when you have a sentence that doesn't fit immediately into that standard form. Okay, so some categorical statements have to be slightly modified to fit the form we're using here. You are allowed to do that as long as we're not really changing the meaning of the sentence. All F are U still sort of means the same thing as everything friendly is cute if we take F to mean friendly things and if we take U to mean cute things. Okay, so we haven't distorted the meaning so out of shape that this is a new sentence. We've just modified it so that it has that kind of grammar that can be recognized by our categories. Okay, so F, friendly things, that has become a class of things, and U, which refers to cute things, has become a class of things, even though in the original sentence we just have cute, right? We just have that attribute. So a little tweaking is sometimes necessary. Some of the class terms have to be adjusted to refer to classes of things instead of mere properties, right? Cuteness, friendliness, those are just properties. We need to transform those into things in order for our subject and predicates to be relating in a way that categorical logic can pick up on. Okay. So notice we have modification of class terms from properties, and then, but really our main transformation is the transformation of content into form. That's really what we're doing when we're formalizing. So let's look at another example here. All romantic novels are literary pieces. All works of fiction are literary pieces. Therefore, all romantic novels are works of fiction. Again, we're not thinking about truth value or truth content. We're just thinking about form. Again, we should have a horizontal line here to indicate the conclusion. Therefore, is a very good indication of our conclusion. But in standard notation, we should have that line here to sort of delimit the difference between the premises and the conclusion. So let's symbolize this argument so we can clear away some of these clunky class terms and some of this non-logical vocabulary into logical units. Let R represent romantic novels. The letter R is going to stand in for romantic novels. Let W stand in for works of fiction. W is a work of fiction. And let L represent literary pieces. Literary pieces. So please rewrite this argument in its formal structure using this notation. Okay, you should have something like this, right? First premise should read all R are L, where R represents romantic novels and L represents literary pieces. Second premise should be all W are L, where W represents works of fiction and L is literary pieces. And then our conclusion, all R are W, where R represents romantic novels and W represents works of fiction. Okay, so this works. And again, each one of these is an A proposition. Each one of these you should recognize as a universal affirmative, where we have this quantifier all, indicating that every member of the subject group is also a member of the predicate group. Okay, so a lot of instances here of universal affirmative sentences. Those do happen, but it won't always be the case. But we're just using it as an example here to get sort of the feel for this formalization. Okay. All right. So that is going to do it for now. I hope that by now you at least are starting to have a sort of a grip on what it means to formalize a content, to formalize an ordinary language argument into standard form, right? We're going to get better and better at this as we do more and more, and eventually we're going to get so good at it that we can completely look at the validity of arguments independently of content. Okay. So make sure you complete the assignment associated with categorical propositions, and we will return to some of the properties that we dealt with in the previous video, referring to the 4 types of categorical proposition. All right, everyone. We will keep working on this, and see you next time.